We're going to continue our journey in electric lighting design by touching on a couple of topics that become extremely popular, not only with lighting design communities, but with the general public. And they really are around healthy lighting. It's kind of the item that people are beginning to think about. How does light affect our sleep patterns, and how does light affect the environment? So we're going to touch on both of those areas, first with the environment, and then delving into circadian rhythm at night and what it does for our sleep. So with the environment, we know that light does affect flora, fauna, and specifically animals grew up, or they evolved with not having light at night and being able to sleep under the moonlight or the stars. But as we start encroaching on their environment, there are some issues. And it could even start encroaching on our own environment, looking into this particular light going into someone's bedroom window. But notice the light right next to the tree, and how does that affect the growth of the tree and because it needs nighttime darkness in order to really replenish itself and to do its own circadian cycle. When we look at melatonin, this is a hormone that every single living creature on earth produces. It's an extremely important hormone for our circadian cycle, and even nocturnal animals produce melatonin. It's not, everyone thinks that you do melatonin when you sleep, but it's not. It's in times of darkness. And this is extremely important. So if any of you kind of take melatonin pills and go, that's great, you do it at night when you're ready to go to sleep and be into darkness. And animals need it too. And if we go over full moonlight levels, then it could start affecting the melatonin suppression or production in every living creature. If we look at the human circadian rhythm, we can see at different times during the day of when melatonin secretion starts and the importance of that in order to sleep. What I like about it is that melatonin secretion starts in the late evening and it goes through until the morning. But at 4:30 a.m., in order to get a really good night's sleep, we need a very low body temperature. And that may not happen if we have suppressed our melatonin. We can actually plot this on what we call a spectral distribution curve and plot the different responses inside of our visual system. The orange curve is our day vision. This is where we see colors, and it's mostly the type of vision, it's called photopic vision, that we experience during the day. Kind of our red, green, blue cones, how we see colors. The green curve is our night vision, and it's done mostly by our peripheral vision. And these are our rods. And notice that they shift down to a bluer wavelength of light for their sensitivity. But just lately, new receptors have been found inside the eye, intrinsically photosensitive retinal cells, and they are called IPRGCs. And notice the dark blue curve, and they are extremely sensitive to blue light. So now let's start looking at some of the light sources that we use, especially LEDs, and how it responds to our circadian rhythm sensitivity curve. Most LEDs have what we call a blue pump in them, and then you cover them with yellow phosphor, and that's how they change colors. But all LEDs with a blue pump do emit light in this area, this kind of action spectrum for our circadian rhythm or for our melatonin, no matter what it is. Now, the warmer the light or the smaller the CCT that we've got at night, that's similar to an incandescent light bulb, where the 5,000 Kelvin or the 10,000 Kelvin is similar to daylight. And so therefore we have a choice of really exposing ourselves to different types of light sources at different times during the day. This was an interesting spectral distribution that we did with the city of San Jose and partnership with Lick Observatory, where they did spectral distribution in the night sky. And you can see all the different light sources and where they peak and the effect on the night sky it was. But the labels in red are the natural phenomena of light. And what the head of the observatory said, Nancy, if you could make a light source that only produced light in those natural phenomena that our ancestors, flora and fauna, are used to, that we would have a home run. And that would be something that we could actually use and not have a problem. But what's happening is that we are producing light below 500 nanometers, which is producing sky glow and all those issues. And if you look at the sun, it really starts telling us exactly what we need. With the blue light during the day, that's the type of light that will entrain our circadian rhythm. And as the sun sets, the blue light is absorbed in the atmosphere and it turns red because only blue light is absorbed. It's kind of telling us, slow down, get rid of the blue light, go to candlelight. And again, this is what our ancestors evolved with and is what we need in today's lighting environment. There's been a lot of work done on, yes, we know what light suppresses us at night, but what about during the day? How do we get the circadian stimulus going so that we get the best, healthiest entrainment? The Lighting Research Center has come up with a terminology called circadian stimulus, and their prediction is if you increase the lighting level or the stimulus by 30% from when our melatonin is not suppressed, that you could start creating a circadian stimulus. And this happens again during the morning is the best time. And at night, again, they say, please reduce your circadian stimulus. So we can go out and measure circadian lighting, and it is done with what we call melanopic ratio. If we have a melanopic ratio of 1 or higher, it really stimulates our circadian system by suppressing our melatonin. But at nighttime, we need a very, very low melanopic ratio, which will help us maintain and produce melatonin. This may look familiar to a lot of you. I hope not, that this is not what you are doing. You can see it's all blue and purple light and a lot of screens. And I think what we need to do is to become more aware of this type of situation and to avoid it. There are different light sources that have been evolving, and this one is an LED that actually has 2 different LED light sources on board. One produces really warm colored light and one produces very cool colored light. And by adjusting them over each other, like you may want to dim the cool colored light and increase the warm colored light, we can actually get different appearances. This particular curve is called the black body radiator curve, and it's a tool that we use to actually look at different light sources and how they present themselves. The Kelvin temperatures, or the K, represents kind of roughly of what the color of light could look at. 3000 Kelvin being a lot warmer, and 6500 degrees Kelvin is very cool and very much like daylight. But we've also noticed that we can manipulate this Kelvin temperature curve by going off and above and below the black body radiator curve. This we can do with what we call spectral tuning light, where we adjust different colors at different ratios. This is very interesting for us to manipulate because many people will say, oh, just do a 3000 Kelvin lamp or a 4000 Kelvin lamp. But we can see that you can adjust this and have very different results. As shown in these pictures, we did kind of study this in our lab. We did spectral distribution, the light sources across, and you can see they're all 4000 Kelvin. But when you're below the black body radiator curve, everything looks really high, or melanopic ratio is higher, versus way below the black body radiator curve, your melanopic ratio is lower. So the best thing to do overall is to get exposure to daylight. Get out there, and the best time is about 9 to noon every single morning. You can do it with electric light, but what I would encourage you is not necessarily rely on the blue light pill, but to really get outside, look at the views, go for a walk, and some way work your life around doing daylight views, all of that. Well, thank you very much. I'd love to know if you have any questions, and if you do, feel free to email me at nancy@clantonassociates.com, and enjoy your day and turn off that blue light at night. Thanks.